By late 2025, something truly extraordinary will unfold in our solar system. 7 sizable comets will make their way into the inner regions of our planetary neighborhood. This is not just a routine cosmic event. It is a convergence so rare that astronomers say the odds of it happening by chance are less than 0.5% per decade. Among these icy wanderers is the remarkable interstellar visitor, 3IATLAS, only the 3rd comet ever detected that originated from beyond our solar system. Its arrival adds an entirely new layer of intrigue to an already rare phenomenon. The timing of these comets is almost unprecedented. Normally, comet sightings are scattered and few, with maybe 2 or 3 bright comets visible in a half-year period. But in this unusual scenario, 7 significant comets will appear in just 6 months, essentially crowding the inner solar system and creating what scientists describe as a celestial traffic jam. The sheer number of visitors passing close to the Sun and the planets is enough to make astronomers and sky watchers alike stop and take notice. This convergence is also a reminder of how dynamic our cosmic environment truly is. Each comet carries its own story, its own chemistry, and its own path through space. For 3IATLAS, the interstellar traveler, the stakes are even higher because it challenges everything we know about comets formed in other star systems. Observers around the world will have a rare opportunity to witness and study not just one, but a cluster of cosmic wanderers in real time. Scientists are already preparing for this event, coordinating telescopes, space missions, and observation campaigns to ensure no detail is missed. From the naked eye to the most sophisticated instruments, 2025 promises a comet season unlike anything experienced in over a century of recorded astronomy. This is more than just a rare sight. It is a chance to explore the mysteries of our solar system and even touch the secrets of distant stars through these icy visitors. In today's world, discovering comets is no longer a matter of chance or months of patient skywatching. Instead, a network of automated telescopes and digital surveys tirelessly sweeps the skies every night. Programs like Pan-STARRS in Hawaii and Chile and ATLAS in South Africa have transformed how we detect and track these icy visitors. Positioned on remote mountaintops with crystal-clear views, these observatories use highly sensitive cameras capable of capturing even the faintest glimmers of light, far dimmer than Pluto appears from Earth. These surveys don't just take pictures. They compare each new image against a digital memory of the night sky. Any slight movement of a single pixel, barely noticeable to the human eye, can reveal the presence of a new comet. Once a candidate is spotted, automatic alerts are sent to astronomers worldwide. Telescopes swing into action, capturing follow-up images, confirming the discovery, and studying the comet before it fades into the background of stars. This relentless digital vigilance has changed the game entirely. In the past, discovering a single comet could take months or even years. Now, the number of detected comets doubles almost every year, allowing astronomers to catalog faint and distant visitors that would have gone unnoticed just 2 decades ago. Minor planet centers log these discoveries, building an ever-growing census of icy wanderers. Yet even with this advanced technology, the sheer number of comets approaching in late 2025 is overwhelming. Engineers and astronomers are watching their monitors more closely than ever, as alerts light up their screens faster than anticipated. For the first time, the machines that usually handle these discoveries automatically are struggling to keep up. This unprecedented digital traffic reflects just how rare and extraordinary the upcoming convergence of comets truly is. To fully appreciate the spectacle of 7 comets arriving in 2025, it helps to understand some key comet science. First, there's perihelion, which is simply the point in a comet's orbit where it comes closest to the Sun. This is where the magic happens. Sunlight heats the frozen nucleus, turning ice into gas and dust, creating the glowing coma and dramatic tails that make comets visible from Earth. Next is the astronomical unit, or AU, which is a standard way astronomers measure distances in the solar system. 1 AU equals the distance from Earth to the Sun, about 93 million miles or 150 million kilometers. So when a comet's perihelion is 0.25 AU, it's just a quarter of the way from the Sun to Earth, bringing it extremely close and potentially bright in our skies. Magnitude is another crucial term, representing a comet's brightness. Lower numbers mean brighter objects. A comet at magnitude 6 is faint, just barely visible to the unaided eye under dark skies, while a magnitude of 3 or 2 can rival the brightest stars. This scale helps sky watchers know what to expect before stepping outside. Finally, understanding comet tails is essential. Every comet grows at least one tail as it nears the Sun. The dust tail is broad, pale, and curved, made of tiny grains pushed away by sunlight. The ion tail is narrow, straight, and blue, created when charged gas interacts with the solar wind. These tails not only make comets visually stunning, but also serve as indicators of space weather. Solar storms can even sever ion tails in dramatic displays, giving scientists a live demonstration of the Sun's invisible forces. Knowing these basics allows both amateur and professional astronomers to decode sky charts, follow comet predictions, and fully enjoy the coming celestial show in 2025. Under normal circumstances, a 6-month period in the solar system might reveal only 2 or 3 bright comets, and even those are considered special events. The typical expectations are modest because comets are governed by the complex physics of their orbits and the random nudges they receive from gravitational interactions or collisions. In distant regions like the Oort cloud, detection technology can help us spot fainter, distant comets, but it cannot create a cluster of major visitors out of thin air. What makes the 2025 225 comet season so remarkable is that 7 significant comets will appear in just half a year. This isn't just unusual, it is a true statistical anomaly. Comet population models, which simulate expected arrivals based on decades of survey data, show that this number is far outside the normal range. In fact, the probability of such a cluster occurring naturally is less than 0.5% per decade, and some models suggest odds as low as 1 in 1,000 years. This extraordinary convergence pushes the limits of our understanding. It raises questions about whether this is a random cosmic coincidence, a sign of some large-scale event far out in the Oort cloud, or simply a statistical fluke amplified by modern detection methods. For astronomers, this cluster is both a challenge and an opportunity. Not only does it test the reliability of comet population models, but it also provides an unprecedented chance to observe multiple comets interacting with the inner solar system in a compressed timeline, giving insight into comet activity, solar interactions, and the dynamics of our cosmic neighborhood. In short, the 2025 comet season isn't just a busy calendar, it's an anomaly that will be studied and referenced for decades, a reminder that the universe occasionally defies expectations in spectacular fashion. Not all comets are created equal when it comes to visibility. Among the 7 visitors arriving in 2025, some will barely make a splash in the night sky, while others are poised to steal the show. Take C2222 Pan-STARRS and 240 P-NEAT, for example. Pan-STARRS will reach perihelion on July 31st at around 382 AU from the Sun, a distance far beyond Mars and closer to Jupiter. At that distance, sunlight barely affects its icy surface, creating only a modest coma. Most casual observers will see little more than a faint smudge, and only telescopes with sensitive detectors will capture its details. Similarly, 240 P-NEAT makes its pass on December 19th at 212 AU, still twice as far from the Sun as Earth. This returning traveler offers a subtle encore, providing dedicated amateur astronomers with a chance to track its path, stack images, and contribute to comet research. These quieter comets are essential for completing the overall census, filling in the faint end of the spectrum and helping scientists understand the diversity of comet behavior. But the other comets in the lineup promise something very different. Dramatic, naked-eye visible displays. They include crowd-pleasers like Swan, Atlas K1, and Lemon, each bringing its own spectacle. Bright tails, vibrant comas, and the potential for unpredictable outbursts make these comets the stars of the 2025 show. Amateur astronomers and casual sky watchers alike will be able to enjoy the visual drama, witnessing comet activity that was once the domain of professional observatories alone. This contrast between faint and spectacular visitors highlights the richness of the 2025 JWST comet season. From dim, distant whispers to blazing sky-filling apparitions, there's something for every observer, reminding us that the universe delivers variety in both subtlety and grandeur. Among the 7 visitors of 2025, 3 comets stand out as the true showstoppers: Swan, C2025 R2, Atlas K1, and Lemon, C2025 A6. Each of these bright comets promises a unique experience for sky watchers, whether you're using binoculars, a small telescope, or even just your eyes. Swan will make its closest approach to Earth on October 21st, coming just a quarter of an astronomical unit away, about 37 million kilometers. This proximity means the comet will shine brightly, potentially reaching magnitude 2 or 3. Its tail, sculpted by the solar wind, is expected to stretch impressively across the sky, making it one of the most memorable naked-eye comets in years. Casual observers stepping outside at dawn could catch a glimpse of this celestial spectacle without any special equipment. Atlas K1 dives even closer to the Sun, reaching perihelion on October 8th at just 0.33 AU, well inside Mercury's orbit. The intense sunlight at this distance is expected to trigger powerful outgassing, creating dramatic jets of gas and dust. Astronomers are eagerly watching for unpredictable surges and sprawling tails that can transform this comet into a dynamic visual show, perfect for photography and detailed observation. Finally, Lemon graces the evening skies starting November 6th, with its closest approach on November 8th at just over half an AU. This comet may brighten to magnitude 3.5 or 4, visible to the naked eye under dark skies, and is ideal for binocular viewing. Its classic evening appearance provides a more relaxed opportunity to enjoy comet watching after sunset, giving a stunning finale to the season's bright arrivals. Together, these 3 comets offer a diverse range of experiences, from dawn to dusk, each with its own personality and activity. Observers can witness cometary tails forming, shifting, and interacting with solar winds in real time, making 2025 a truly remarkable year for both amateur and professional sky watchers. Not every comet in the 2025 feast lineup will put on a show visible from Earth. Some, like 414P, stereo, pass so close to the Sun that they remain hidden in the Sun's glare for ground-based observers. At its perihelion on September 27th, 414P will swing just over half an astronomical unit from the Sun, closer than Venus, making it virtually invisible from Earth. This is where specialized spacecraft like SOHO and stereo play a crucial role. These missions were designed to monitor the Sun and its corona, but their cameras also capture comets as bright streaks against the solar background. Observations from these spacecraft reveal details of cometary activity, including tail formation, outgassing, and interactions with solar wind, that ground-based telescopes simply cannot see. The global astronomical community coordinates carefully to ensure that every comet receives attention. NASA, ESA, and other observatories plan observation schedules to capture data from different angles. Spacecraft track the hidden visitors, while ground-based telescopes focus on the brighter comets visible in our skies. This collaborative approach creates a complete picture of the 2025 JWST comet season, blending the strengths of both Earth and space-based instruments. By combining observations from multiple platforms, scientists can study the comet's interactions with the solar environment, measure tail disconnection events caused by solar storms, and capture fleeting outbursts. The result is a richly detailed record of comet behavior that will help astronomers understand not just individual comets, but the dynamics of the inner solar system during an unusually crowded and active season. One of the most captivating aspects of observing comets is watching their tails, which reveal the invisible forces at play in our solar system. Comets develop two main types of tails as they approach the Sun: a dust tail and an ion tail. The dust tail is broad, pale, and often slightly curved, made of tiny grains pushed away from the comet by sunlight. These particles scatter sunlight in all directions, creating a luminous, sometimes golden glow that can stretch for millions of kilometers. The dust tail follows the comet's orbital path like a glowing wake, offering a gentle and graceful display across the sky. In contrast, the ion tail is a narrow, electric blue blade that always points directly away from the Sun. It forms when ultraviolet light strips electrons from gas molecules in the coma, turning them into ions. The solar wind, a stream of charged particles flowing outward from the Sun, then hurls these ions straight away, no matter which direction the comet is moving. Solar activity can dramatically reshape these tails in real time. Powerful coronal mass ejections, or CMEs, can sever ion tails within minutes, an event called magnetic reconnection. Observers have caught these spectacular disruptions before, like the famous 2007 event, when NASA's Stereo spacecraft recorded a comet's ion tail being sliced away in an instant. With 7 comets converging in late 2025, the chances of witnessing such dynamic tail behavior are higher than ever. Each CME that sweeps through the inner solar system becomes a dice roll for which comets might display sudden tail breaks. For astronomers and skywatchers alike, these events provide instant, visual reports of space weather, showing the Sun's magnetic influence on a cosmic stage. By following these tails, observers can see the delicate interplay of sunlight, gas, dust, and solar activity in real time, turning the sky into a living laboratory where the invisible forces of the solar system are written across the heavens. Among the 7 visitors in 2025, 3IATLAS stands apart as a true interstellar traveler, the third comet ever confirmed to originate from outside our solar system. What makes this comet extraordinary is not just its path through the solar system, but its enormous size and unique chemistry. Observations from the Hubble Space Telescope, James Webb Space Telescope, and ground-based observatories reveal that its coma, the glowing envelope of gas and dust surrounding the nucleus, stretches nearly 700,000 kilometers across. To put that in perspective, that's almost half the diameter of the Sun and more than 50 times wider than Jupiter. The tiny rocky nucleus at the center is almost invisible, dwarfed by the sheer scale of its surrounding cloud. Even more remarkable is the composition of 3IATLAS. Unlike most comets, where water vapor dominates, this interstellar visitor is dominated by carbon dioxide, with an 8.1 ratio of CO2 to water. The CO2 jets erupt from the nucleus with incredible force, shaping the coma and fueling the twin tails. Dust ejection rates reach up to 6 kilograms per second for fine grains, and as much as 60 kilograms per second for larger particles, equivalent to tossing a bowling ball into space every second. These jets and outbursts shift constantly, creating a living, breathing structure that evolves hour by hour, influenced by the comet's rotation, sunlight, and space weather. This unusual chemistry has planetary scientists buzzing. Was 3IATLAS formed in a frigid region of another star system, allowing CO2 to freeze in bulk? Or is there a hidden layer of water ice beneath an insulating crust? Spectroscopy teams using JWST, SPHX, and other instruments are working around the clock to answer these questions, analyzing every spectrum for hints of its origin. The story doesn't end there. Post-perihelion, the dust trail of 3IATLAS may cross Earth's orbit in mid-2026. Meteor scientists are already preparing to track these particles with radar and airborne campaigns, aiming to capture even a single grain of interstellar material as it burns up in our atmosphere. Successfully collecting such material could provide the first direct sample of matter from another star, offering insights into isotopes and molecules completely untouched by our solar system's history. For astronomers, each new observation of 3IATLAS is a ticket to the frontier of planetary science. Its enormous coma, volatile activity, and unique chemistry provide real-time lessons in comet mechanics, tail formation, and interstellar chemistry. As we watch this interstellar wanderer thread its hyperbolic path through our solar system, we're witnessing a cosmic visitor unlike any other, offering a rare chance to expand our understanding of worlds beyond the sun. Despite the dramatic headlines and social media speculation, all 7 comets in the 2025 lineup pose no risk to Earth. Professional astronomers around the world have tracked and recalculated their orbits using the world's largest telescopes and the Minor Planet Center's global database. Every comet follows a well-mapped trajectory, with the closest approach being Comet Swan on October 21st at 37 million kilometers, more than 90 times the distance to the Moon. The other comets pass even farther out, safely guided by gravity alone. There is no physical mechanism by which this cluster could trigger earthquakes, storms, or other disasters. Instead of danger, this crowded comet season offers an extraordinary scientific and observational opportunity. Astronomers can monitor multiple comets in real time, studying tail formation, outgassing, chemical composition, and interactions with solar activity. Spacecraft and ground-based telescopes coordinate to cover all angles, ensuring that no visitor goes unobserved. For the public, the 2025 Comet Cluster provides rare and exciting opportunities for naked eye or binocular comet watching. From early morning views of Swan on October 21st to evening glimpses of Lemon in November, anyone with dark skies and a clear horizon can participate. Simple tools like a star map, a phone app, or even a compass can help locate the comets, while patience and regular observation reveal how the tails and comas evolve night by night. Ultimately, this season is a reminder of the beauty and wonder of the cosmos. Rather than fear, the message is clear. Look up, observe, and enjoy a once-in-a-lifetime celestial parade. Late 2025 and 2026 will be remembered not as a threat, but as a golden window for discovery, study, and shared human awe at the moving sky above us.